On this driveway, a worker moves a ladder. As the frame moves, an unsecured power drill resting on top slides loose and drops into the overhead work path. Loose tools should be removed before any elevated structure is moved. In this busy shipping yard, a driver waits inside his parked vehicle, but from the blind spot high above, a massive steel container unexpectedly shifts from the lifting path. Suspended containers carry overhead risk across every space below the lifting path. If rigging control weakens or the container shifts unexpectedly, the full load can move downward faster than the area can be cleared. Vehicles, cabins, and nearby structures should never be treated as protection beneath industrial lifting operations, because true control comes from keeping the entire load path empty. Protection beneath active lifting operations requires complete overhead separation. At a patio, a heavy slab is lifted from the ground. Unaware it covers a hidden floor opening, the next movement forward exposes the missing support surface beneath the setup. A covered hole can look like normal ground until the cover is moved. When a heavy slab is lifted, weight may shift toward the opening before the missing support is clearly visible. The cover can also block the view of the edge until it is already exposed. Any hidden opening should be treated as an active risk until the area is inspected and marked. Check beneath covers before moving them. Stand to the side, not over the unknown space. Mark and protect openings immediately after they are uncovered. Inside a quiet courtyard, pressure is applied near the base of a crumbling brick wall. The weakened structure gives way, filling the area with heavy, loose material. A weakened wall can still hold stored structural force. When pressure is applied near the base, the last support keeping the section upright may shift. Once that support moves, the wall can release in one motion and send loose brick material across the area. Safer demolition begins with checking cracks, judging stability, moving activity away from the release path, and setting a clear area before work begins. Test wall stability before demolition work. Mark clear areas around release paths. Use debris shields where material may shift. In a material yard, a low work position forms near the ground. However, a massive dump truck reverses into the same rear wheel path without warning. Working low behind heavy equipment creates a position that can disappear from the operator's view. Drivers seated high in the cabin may have little visibility directly behind the tailgate. As tons of steel move backwards, engine noise can hide the direction change. A low, stationary position in a blind spot places the work area directly in the rear travel path. Set a protected space before dropping low. Assume idle vehicles may move until parked, locked, and confirmed still. Use eye contact before working near the rear of the equipment. A massive truck reverses steadily on a paved industrial lot. Without warning, the rear tire sinks through a weak surface, causing the vehicle to lose side stability. Heavy vehicles place enormous pressure onto small contact points where the tires meet the ground. A paved surface can look strong while hiding soft soil, voids, water damage, or weak fill underneath. When one wheel sinks suddenly, the truck's support base changes instantly, and the center of gravity shifts toward the failed side. If the load is raised or uneven, the tipping risk becomes even greater. The safe approach is to inspect travel paths before reversing, test questionable ground, avoid unsupported edges, and confirm that pavement can handle the vehicle weight. On a busy textile factory floor, cleaning takes place near an active spinning machine. Loose fabric contacts the rotating shafts and begins catching on the mechanism. Fast-moving parts can pull in fabric the moment it touches rotation. When loose garments pass near exposed shafts, the material can catch and wind tighter with every turn. The equipment continues with steady power, moving cloth toward the frame faster than reaction can stop it. Cleaning near active spindles should only happen with secured clothing, fixed guards, and separation. Sleeves, scarves, and hanging material must stay away from open rotation before work begins. Secure garments tightly near active equipment. Install solid shields over spinning components. Keep cleaning tools separated from continuous motion. On this active factory floor, a worker enters the adjustment area of a heavy hydraulic press to clear a jammed board, but the massive steel canopy above still carries active mechanical pressure. A hydraulic press remains hazardous whenever stored energy or automated motion is still active inside the system. Entering the adjustment area without full isolation allows the machine to continue its cycle while the operating space is occupied. Press maintenance must begin with lockout, verified zero energy, and interlocked guarding to prevent mechanical movement during clearing or adjustment tasks. Safe maintenance requires complete energy isolation before entering active machinery areas. Physical lockout systems remain critical for controlling unexpected motion. At an industrial site, a trailer door is opened during strong wind. The wind catches the large panel, driving it through the work area. Large trailer doors can act like sails when strong wind hits them. A wide metal panel collects air pressure and can move with surprising speed once it is unlatched. The swing path may cross the same space used for walking, loading, or checking the trailer. If the door is not secured, every gust can change its direction and force. Secure doors with proper latches before working nearby. In an unloading area, heavy panels are guided off a delivery truck. The standing stack shifts and releases material into the active work path. Vertical stacks rely heavily on balance when not tied, braced, or separated. When boards lean together, their weight creates a strong sliding force. A small movement near the base can change the stack and send material beside the truck. The nearby path can close before there is time to move clear. Better control comes from binding the stack first, keeping hands and feet out of the release path, and unloading sheets in sections. Secure standing boards with ratchet straps before unloading. Establish clear areas away from vehicle edges. Move heavy sheets individually for control. High atop a massive industrial tower, a worker strikes an electric welding arc. The sudden spark ignites trapped chemical fumes, triggering a massive pressure release. Applying intense heat near fresh chemical coatings creates an ignition risk. Without proper ventilation, flammable vapors can gather quietly inside enclosed tanks or tower sections. When a spark meets concentrated gas, pressure can rise in a fraction of a second. That pressure can force steel panels outward, push materials into surrounding areas, and make the structure an uncontrolled release point. Test the atmosphere before hot work. Keep fresh airflow moving, clear the surrounding area, and respect invisible vapor buildup before one spark changes the job. At a construction site, a crane lifts a heavy machine. The rigging fails, and the load loses support and moves downward to the ground. A lift is only as safe as the weakest part of the rigging system. Slings, hooks, shackles, anchor points, and connection angles must all match the weight and movement of the load. When any part fails, the machine no longer has controlled support, and gravity takes over immediately. The load does not need much height to create high force when it moves downward. A controlled lift requires verified weight limits, proper rigging selection, balanced connection points, backup planning, and a fully cleared lower path before the crane takes tension. At a residential construction site, a scissor lift is driven up a makeshift wooden ramp. The incline shifts and the machine loses stability. Mobile elevating platforms need firm, level support to keep their balance. When heavy machines travel onto temporary inclines, the center of gravity changes quickly. If the ramp flexes, slips, or settles, the machine base can no longer stay even. Weight then moves toward the low side, creating a tipping motion with little room to recover. Safer movement depends on rated access routes, checked ground strength, low platform height, and avoiding improvised temporary ramps. Along this canal bank, a fisherman raises his long rod toward the water, but inches above, an energized overhead cable hangs silently across the open air. Overhead cables must be treated as active energy sources even when they appear still and silent. Long rods, poles, and conductive tools can reduce clearance enough for electrical energy to transfer through the air or the material. Safe work near overhead utilities depends on distance first, because once the energy path forms, control of the surrounding movement can change instantly. Strong electrical safety depends on maintaining wide clearance around overhead infrastructure. Environmental awareness should always come before raising long equipment near utility lines. Suspended wires must always be treated as active energy sources. In an open courtyard, concrete is washed using an electric cleaning device. Electrical leakage energizes the wet surface and turns the area into an active current path. Water can carry electricity across a wider area than expected. If a tool, cable, plug, or motor leaks current, the wet surface may become part of the circuit. Normal control of the equipment may be lost, especially when hands, shoes, and floor are damp. Outdoor electrical cleaning needs ground fault protection, dry connections, and checked cables before the work begins. Use ground fault circuit interrupter protection for wet electrical tasks. Inspect cords and plugs carefully. If current is suspected, disconnect power first before any contact or access resumes. In a workshop, maintenance begins beneath a motorized tricycle's raised cargo bed. The heavy structure lowers into the open service space below. Raised vehicle beds should not depend on hydraulic pressure alone for support. A small leak, weak cylinder, worn pin, or control failure can allow the tray to lower without warning. Once the structure begins moving, its weight follows the open space beneath it. In a tight workshop, there is little room to reposition after support is lost. Repair work needs a solid block that can hold the load, plus a check before maintenance. Block raised beds with solid steel props before maintenance. Inspect lifting cylinders for hidden fluid leaks. In a quiet industrial yard, a man walks behind a massive delivery truck. The heavy vehicle reverses, silently closing the rear travel path. Tall cargo boxes block rear vision from the cabin, creating areas where ground-level movement can disappear from view. As the vehicle moves backward, engine noise and yard activity can hide its approach. This mix of poor visibility and loud surroundings creates immediate rear path exposure. Once heavy tires are moving, the safer response is to avoid the rear path entirely until the vehicle has passed. Regard the space behind vehicles as an active movement path. Lock eyes with the operator, wait for moving metal to pass, and cross only when clear. In a private garden, ladder work takes place while high tree branches are being cut. The heavy limb releases unexpectedly, pulling the setup out of balance. Cutting heavy branches from a ladder combines two unstable forces at once, the shifting weight of the branch and the narrow support of the ladder. When the branch releases, it can swing, move downward, or pull in a direction that changes the balance of the cutting position. Tree work should be planned from a stable platform whenever possible, with ropes controlling the limb, a clear cut sequence, and both hands free from the branch's movement path. At an entrance, seating is used on a yellow barrier gate. A delivery cart contacts the frame, and the barrier loses support under the added weight. Traffic barriers are built to guide movement, not to carry seated weight. When a cart or vehicle contacts the frame, the barrier can bend, twist, and rebound quickly. Energy travels through the metal, turning a resting spot into moving equipment. Safer site control means keeping barriers for traffic guidance only, placing seating outside vehicle routes, and treating extendable frames as moving parts. In a quiet yard, a worker unlatches the back doors of a truck. But behind the metal doors, a large stack of unstable goods has shifted heavily during transport. Cargo inside a truck can shift heavily during transport and press against the rear doors long before unloading begins. When the latch is released, the door may be the only barrier holding the unstable stack in place. Trailer doors should always be opened from a protected side position, with cargo restraints verified before the load is allowed to move into the unloading area. Preventing load movement begins with properly securing cargo before transport begins. Every shipment requires reliable restraints to reduce shifting during travel. Inside a busy box factory, material is cleared from an active machine. A clearing attempt brings material too close to the rotating press, and the intake point catches the material. A press does not slow down just because a jam is being cleared. Rollers and plates keep moving with steady force while drawing material through the gap. When tools or loose scraps enter that intake area, control can be lost quickly. The only safe way to clear a blockage is to stop, isolate, and verify that all motion has ended. Shut down the machine before clearing jams. Use lockout procedures every time maintenance begins. Guards, tools, and safe distance should protect the intake point during normal operation. At a recycling plant, access occurs inside a dormant industrial grinder before full isolation. The machine restarts and internal components begin moving beneath the access area. Industrial machines can restart with torque when energy has not been fully isolated. Equipment that appears dormant may still have active controls, stored power, or automatic cycles ready to engage. Once heavy components begin turning, the inside area loses stable footing and pulls loose material toward moving parts. The inside of a grinder is not a workspace until energy is locked, tested, and blocked. Lock all energy sources before entering dormant equipment. Install loud pre-start alarms before movement. In a rocky valley, a towering machine lifts a massive concrete pillar, but the long steel arm fails, sending heavy metal and concrete downward into the work area. Pushing mechanical limits creates an unpredictable breaking point. When extreme weight overwhelms heavy steel supports, the towering structure can fail instantly. The failure sends the arm rigging and supported material downward with full load energy. Any position near the lifting path is too close once failure begins, so wide boundaries must be built early, well before the lift starts. Establish broad exclusion areas before heavy lifting. Respect rated capacity, keep observation points well away, and give every lift the space it needs to fail safely. Inside a warehouse, a loader moves with a raised bucket. The rear tires lift off the ground, causing the heavy load to spill forward as the machine loses balance. Raising heavy material high changes the balance of a loader by moving the center of gravity upward and forward. When the machine travels with the bucket elevated, every bump, stop, slope, or steering change adds more tipping force. Once the rear tires lift, the machine has already lost stable ground contact, and the operator has very little control left. The safest travel position is low, slow, and balanced, with the load close to the ground and the path checked before movement begins. Stability should always come before speed when transporting heavy material. On a roadside work area, a forklift moves across uneven ground while carrying a load with the mast raised high. The machine loses lateral stability. A raised mast moves a forklift's center of gravity upward and reduces the angle the machine can safely tolerate. When wheels pass over uneven ground, that higher balance point makes small surface changes serious. The forklift can shift faster than steering, or braking can correct. High loads also add sway, making the machine top-heavy during travel. Keeping the load low gives the tires and frame a better chance to stay stable over bumps. Lower heavy loads near floor level before driving and inspect travel surfaces for dips or debris. In the snowy courtyard, a worker stands high on a leaning stepladder to reach the roof, but the frozen ground beneath the metal feet offers very little grip. A ladder on icy ground loses the friction needed to hold its base steady under climbing pressure. As the weight rises higher, the center of gravity shifts and pushes more force into the ladder feet. Without dry contact, anchoring, or anti-slip support, the base can slide away and remove the stable access point needed for elevated work. Safe winter access requires securing a stable footing before climbing begins. Every ladder setup depends on dry, level surface contact to maintain proper support. At a factory yard, active tree cutting takes place near overhead lines. A moving trunk section contacts a wire, transferring force into a nearby concrete support. Overhead lines can carry force far beyond the tree being cut. When a trunk contacts a cable, the pull can travel through wires, poles, brackets, and anchors. A work area that seemed outside the tree path can still be affected by the tension in the connected line. Tree cutting near overhead systems requires planning for every object linked to the cable. Map wires, poles, and supports before cutting begins. Keep the clear area wider than the expected tree path. Control the tree with proper equipment, not guesswork. In an industrial yard, a walkway passes near a forklift handling stacked containers. The unstable top crate slides free and releases toward the walking route. Stacked heavy materials need balance, binding, and a clear lift plan before movement. Forklifts lifting multiple containers depend on a steady center of gravity to keep each layer in place. If the upper section shifts, it can slide from the forks. The walking path can fill quickly, leaving little space to react. Passing close to active lifting work removes the safe margin needed when loads shift. Safer handling uses strapped stacks, cleared paths, and single-level transport. Bind stacked containers with industrial ratchet straps and establish clear areas during vertical lifting. On a smooth deck, a man climbs high up an extension ladder. Suddenly, the unsecured base slips backward, turning a routine ascent into a rapid loss of support, leaning tall equipment against an edge. Without anchoring, the base creates a severe slip risk. As weight moves higher, the center of balance shifts upward and outward. That pressure pushes against smooth surfaces that may not provide enough friction. The bottom feet can lose grip and slide backward rapidly, causing the ladder to lose position with little time to correct. Solid ground grip controls vertical stability. Lock the bottom feet against a strong anchor, maintain the correct climbing angle, and confirm the ladder cannot slide before climbing. Inside a warehouse, a forklift with its forward view blocked by a massive load enters a shared pedestrian path. Large forklift loads can completely block the operator's forward view, creating blind areas directly in front of the machine. When visibility is reduced, nearby movement may disappear behind the load even when it is close to the travel path. The risk grows when pedestrians and forklifts share the same space without clear lanes, signals, or spotters. Safe movement requires separated walkways, audible warnings, controlled speed, and direct visual contact between operators and anyone nearby. If the load blocks the view, the forklift should travel in a safer orientation or use a guide. High on a steep residential roof, access relies on a wooden roof ladder. The fragile frame fails, and the setup begins an uncontrolled downhill slide. Aging timber should be checked carefully before it carries weight above a steep surface. Weather can weaken wood from the inside, leaving cracks, soft spots, or rot that are not obvious during a quick look. When the frame fails, support is lost at once. On slick roof tiles, the angle gives little grip, so equipment and footing can move downhill. Safer roof access uses inspected gear, secured ladders, reliable anchors, and rated equipment. Inspect climbing gear for hidden rot or cracks and use heavy-duty frames for elevated roof tasks. In this loading yard, a worker leans through the truck's side rail opening, but the heavy hinged metal unexpectedly swings downward without support. Hinged metal barriers can move with heavy force when they are unlatched, unsupported, or left under gravity's control. Reaching through the opening places the surrounding space directly inside the swing path of the steel. Before any loading task continues, folding rails and side gates must be locked, supported, or fully controlled so the moving framework cannot close unexpectedly. Maintaining full separation from moving frameworks remains one of the safest approaches during loading operations. Reaching through unsecured barriers increases exposure to unexpected mechanical movement. Hinged structures should always be firmly secured before anyone approaches. High above an extraction site, an excavator moves near an exposed cut edge. The tracks pass beyond stable ground, and the machine moves beyond stable support. Tracked equipment needs firm ground under the full machine, not just under part of it. Near a cut edge or drop-off, the soil can break, crumble, or give way under concentrated weight. Once the tracks pass the balance point, the excavator's mass pulls it forward, and normal controls cannot restore stable contact. Edge work demands physical barriers and clear machine limits. Keep heavy equipment back from exposed edges. Mark limits clearly before movement begins. Use spotters, berms, and stable roots so the machine does not depend on weak ground. In an unloading area, cabin access begins on a tracked excavator sitting on a transport truck. The engine starts, and the machine begins rolling down the steep loading ramp. Equipment on steep transport ramps depends on secure restraints before entry or startup. Starting the engine can change brake status, release movement, or allow tracks to shift on metal. Gravity can pull the machine down the incline quickly, with little recovery time. Metal tracks may also slide on steep, wet, oily, or dirty ramps. Safer offloading requires flat positioning, chains, track blocks, checked brakes, and clear routing. Secure heavy tracks with tension chains before cabin access and engage secondary brakes before starting the engine. Two men wait on an industrial construction hoist high inside a dark building shaft. One takes a casual step backwards and moves beyond the marked floor boundary behind him. Open edges on elevated platforms create sudden and easily missed exposure. When people move backward without checking surroundings, they can cross the safe boundary before noticing the edge. An unguarded opening leaves very little room for correction once the boundary is crossed. Strong barricades, clear edge markings, and constant floor awareness must be in place before anyone waits or works near a shaft. Keep floor boundaries in view before shifting position. Block open floor edges with solid barricades, mark them clearly, and treat waiting areas like active work areas. At an excavation site, an excavator bucket is used for access into a trench. Instantly, the unstable wall releases, allowing a heavy movement of soil into the open space. Using an excavator bucket for transport places access inside an area not designed for safe entry. Around open trenches, the machine's weight, vibration, and movement can disturb already unstable soil. If the trench wall loses strength, the earth can move quickly and fill the lower space before normal reaction is possible. Excavations require designed access points, tested soil conditions, reinforced trench protection, and strict control of equipment movement near the edge. A descent should depend on a proper access route, not a bucket, especially when the ground itself is unstable. At a construction site, viewing happens near a towering crane lift holding a heavy concrete panel. The frame loses structural stability, sending steel and load material downward. Lifting equipment can fail quickly when pushed beyond rated structural limits. The boom, cables, and frame carry immense tension while holding suspended weight. If any support weakens, the lift can change from controlled movement to structural failure in moments. Downward moving steel and material leave no dependable reaction time inside the lift path. Close viewing positions reduce the space needed to move clear. Safe lifting requires load calculations, inspections, communication, and wide boundaries around the lifting area. Verify exact capacities before raising the weight and inspect the metal beams for hidden stress fractures. At this street loading zone, a rider balances a heavy motorcycle on a box truck ramp, but an unexpected remote command suddenly lowers the platform beneath the wheels. Hydraulic lift gates change elevation quickly, and that movement can remove stable support from anything positioned on the platform. When a remote command starts without clear coordination, the load, wheels, and platform no longer move as one controlled system. Lift operation must always require visual confirmation, communication, and stable positioning before any upward or downward motion begins. Clear communication is essential during automated loading operations. Activating lift platforms requires full visual confirmation from everyone directly involved. Stable positioning should always be verified before beginning any descent. At an industrial gate, an incoming cargo tractor turns into the site. During the turn, heavy, unsecured rolls shift sideways from the flatbed into the surrounding path. Cylindrical freight is naturally difficult to control because it can roll when lateral force builds. During a turn, the load wants to continue outward while the truck changes direction. Without straps, wedges, or rated restraints, the rolls can move beyond restraint and enter nearby space. The outside of a turning vehicle should stay clear whenever round cargo is being transported. Secure rolling cargo with proper restraints. Keep distance from turning trucks. Check bindings before travel, especially when the route includes corners, slopes, or uneven ground. In an auto shop, a front guiding directs a moving vehicle into a service bay. The car moves forward suddenly toward the metal workbench. Guiding an active vehicle from the front places the signal position inside the direct travel path. If the driver presses the wrong pedal, brakes respond late, or the floor is slick, the vehicle can move forward in a moment. A tight service bay leaves little clearance between the car and fixed equipment. Standing to the side preserves escape and keeps communication clear outside the path. Safer alignment uses side positioning, clear signals, mirrors, and tire stops. Stand to the side when directing drivers. Install wall mirrors for safer alignment. Bolt firm tire stops into the concrete floor. On a factory floor, a worker walks past a massive stamping press. Without warning, an overhead crane loses control of a heavy steel die near the walking path. Suspended loads store immense energy even when they appear steady. When lifting gear snags, slips, or releases during transport, control can vanish instantly. Gravity pulls massive metal blocks downward with force that cannot be managed from the floor. A position near the load path has little margin once movement changes, so the floor beneath suspended weight should stay empty before the crane travels. Keep wide distance from moving overhead machinery. Treat the floor beneath suspended weight as an active load path. A car cruises down an open highway when a crane boom suddenly loses support from a nearby construction site, entering the vehicle's travel path. Large construction equipment must remain stable even while operating near public roads. Crane booms depend on proper setup, ground support, rigging control, counterweight balance, and structural condition. If any part of that system fails, the boom can move outside the controlled work area and enter nearby traffic space. Drivers passing the site may have very little warning because the movement happens above and beside the road. Work near highways should include strong exclusion boundaries, secured equipment, traffic controls, overhead monitoring, and enough distance to keep public vehicles away from any possible equipment movement path. In a repair yard, tire inflation occurs close to a massive truck wheel. Pressure releases from the tire assembly, sending rapid air and loose material. Adding air to heavy rubber builds strong internal pressure inside the tire. If the casing, bead, or rim has hidden damage, it may not contain the stress. A rapid pressure release can travel outward in a wide path from it. Working directly over the tire places the upper area close to release. Because failure can happen without warning, distance and shielding are essential. Safer work uses a cage, extended hose, inspection, and wheel distance. Inflate heavy wheels inside steel safety cages. Use extended hoses to stand farther away. Inspect tire walls for hidden cracks. Outside this quiet diner, an unmanned three-wheeled machine begins rolling backward down an incline. Within seconds, the uncontrolled equipment reaches the storefront. Unsecured equipment on a slope can begin moving as soon as gravity overcomes friction and brake resistance. Once momentum builds, even a small machine can travel far enough to damage structures and scatter materials across public space. Parking on any incline requires mechanical locks, wheel restraints, and protective barriers, so unmanned equipment cannot roll into occupied or fragile areas. Safe parking procedures require reliable mechanical locks to prevent unintended movement. At a warehouse, the nearby floor area remains occupied beside an active forklift. The unbalanced machine tips and its load moves into the nearby floor area. A forklift can become unstable when the load is too heavy, too high, or too far forward. The machine's balance depends on the load center staying within rated limits. If weight shifts beyond that point, the forklift can tilt before stable control is restored. The area beside and in front of the machine should remain clear whenever heavy material is raised or transported. Check capacity before lifting. Keep loads low and centered while moving. Create a clear perimeter around forklifts so load movement does not enter occupied space. In a quiet workshop, a loaded transport frame is pulled across the floor. The towering weight loses balance and tips forward across the path. Tall frames carrying materials have a center of gravity that can shift quickly. When the frame is pulled from the front, the load may move past its balance point before the wheels can follow. Once momentum takes over, the weight continues with more force than hand control can manage. A blocked wheel, uneven floor, or sharp pull increases the chance of tipping. Safer movement uses side control, slow travel, secured materials, checked wheels, and clear routing. On a bright factory floor, an overhead crane lowers a massive steel coil. During the lift, the rigging slips, sending the huge weight downward toward a nearby work area. Suspended heavy loads carry hidden energy. When a lifting strap loses grip, mechanical control disappears and gravity pulls the solid weight downward. First contact can make a round steel cylinder bounce, roll, or shift unpredictably off elevated surfaces. Any position inside the immediate drop path is too close once movement begins, so distance must be created well before lifting starts. Set wide clearance well before crane work begins. Keep the ground around transport vehicles open, expect rolling movement from round loads, and avoid holding position near moving steel. A flatbed truck makes a sharp turn, and unsecured heavy glass sheets slide away from the rack. The shifting weight pushes into the open truck bed area. Heavy glass panels must be secured against both forward movement and side movement before a vehicle starts moving. During a turn, the load wants to keep moving in its original direction, which creates strong side pressure against the rack and restraints. If straps, wedges, or braces are weak or missing, the panels can slide, tilt, or leave the rack. An open truck bed can then become part of the load's movement path. Safe transport requires rated restraints, strong bracing, pre-trip checks, empty truck beds during movement, and wide clearance around the flatbed whenever glass is being moved. In a fabrication shop, hot work seals the steel tank. Pressure inside the vessel releases, creating a sudden pressure release event across the workspace. Heating enclosed metal containers can expand trapped gases or activate hidden vapors inside the shell. Even when the outside looks clean, fumes may remain in seams, residue, or low areas. If pressure rises while the vessel is sealed, the metal has no safe path to vent. The shell can open quickly and send force through the work area. Safer hot work on tanks requires cleaning, air testing, ventilation, open ports, and a permit process. Flush enclosed spaces with fresh air before work. Test the inside for invisible fumes. Open access ports so pressure can escape. In this dusty yard, a worker steps into the front travel path of a massive concrete mixer, but the elevated cab completely blocks the operator's forward view. Large industrial vehicles often have blind areas that hide movement directly in front of the cab. If the vehicle starts forward without confirmed visibility, the available clearance in the travel path can disappear almost immediately. Safe vehicle movement depends on separated routes, clear operator communication, and strict control of the front path before the machine begins to move. Safe transport environments require strict separation between pedestrian routes and active machinery paths. Ground personnel should maintain clear visual communication with operators before crossing any vehicle route. Continuous spatial awareness greatly reduces vehicle path exposure. On a paved driveway, a heavy gas cylinder is being adjusted. The valve releases without warning, creating uncontrolled cylinder movement across the surface. Compressed gas stores energy even when the cylinder appears still. If the valve or threads fail, escaping pressure can push the tank in random directions. The force may lift, spin, or slide the cylinder across the surface before stable control is restored. Because the movement is unpredictable, cylinders must be protected before any handling, transport, or storage begins. Keep valve caps installed when cylinders are not in use. Secure tanks upright to fix supports. Inspect threads, valves, and fittings before opening or moving pressurized containers. On an active street, a scooter moves behind a reversing paving machine. The heavy steel drum continues backward as small traffic enters the rear travel path. Reversing heavy equipment creates blind spots close to the ground. Smaller vehicles can disappear from the operator's view, especially behind frames, rollers, and steel drums. If traffic enters that hidden space, the machine may continue moving before the operator realizes the path is occupied. The weight and slow stopping response of paving equipment leave little room for recovery. Active paving lanes need separation from public traffic, spotters, barriers, signals, and visual contact before passing. Inside a very busy sawmill, a worker feeds timber into an industrial saw. During the cut, the spinning blade binds and sends heavy wood backwards through the cutting line. When a fast blade catches dense wood, rotational energy transfers into the material instantly. Sudden friction can pull timber out of stable control and send it backward quickly. The wood travels along the cutting line faster than a person can respond. Standing behind the feed path places the work position in the same line as reversing material, making guards, push tools, and side positioning essential. Stand outside the cutting line, use guards and push tools, keep hands clear of feed pressure, and respect how quickly spinning metal can move timber. In a busy warehouse, a forklift operator inserts forks into a load on a truck bed, causing the cargo to shift. Loading and unloading require full separation between machinery and anyone on the truck bed. When a forklift engages a load, the forks can lift, tilt, drag, or push the cargo in ways that are difficult to predict from close range. A standing position on the vehicle bed may be hidden from the operator's view, especially around stacked materials or large pallets. The safe method is to clear the truck bed first, confirm signals between the operator and ground team, and keep everyone outside the load movement path until the cargo is stable and the forklift has stopped. On an extraction site road, foot traffic enters an active haul route and pauses in the lane. A dump truck moves into the same travel path. Large industrial vehicles have elevated cabins that can hide ground-level areas nearby. When foot traffic remains in an active hauling lane, it may disappear from the driver's view. These trucks need long stopping distance because of size, load, and road conditions. Once the vehicle path closes, there is little time for correction. Safer haul roads use separated walking routes, bright visibility clothing, radio contact, marked crossings, and rules keeping foot traffic clear. Build walking paths away from active vehicle. Routes. Wear bright clothing against the terrain. Require radio confirmation before entering haul roads. At this busy warehouse yard, a forklift strains to lift a massive metal cylinder structure, but nearby, an unaware worker stands close to the shifting balance point. Extreme lifting pushes forklifts and similar machines close to their stability limits, especially when the load is oversized or raised away from the center line. Once the weight moves beyond the balance point, the equipment can pivot and redirect the load across the surrounding area. Heavy lifts need firm exclusion boundaries, rated equipment, and continuous control of the load's center of gravity. Safe lifting operations require rigid exclusion zones around all suspended loads. Maintaining strong physical distance remains one of the most effective protections against unexpected equipment instability. A wheelbarrow is used to block a high-pressure pipe outlet. The water force pushes the equipment backward and sends the setup out of control. High-pressure discharge can carry far more force than it appears to have. When an outlet is blocked with loose equipment, the flow redirects its energy into that object. The wheelbarrow becomes part of the pressure path and can move quickly across the wet surface. Water under pressure should be managed with valves, drains, and engineered deflection, not improvised barriers. Control pressurized flow with proper fittings. Keep loose equipment away from active outlets. Stand clear until the line is depressurized. Overhead anchors. At a dusty renovation site, a worker uses physical force on a weakened brick wall. As the heavy structure breaks apart, the unexpected happens. Striking large structural elements can trigger unpredictable movement. When solid walls break apart, heavy debris can cover the path out. Loose rubble removes floor traction exactly when stable movement is needed. Gravity pulls broken masonry downward and outward, filling the nearby work area with material. Demolition should happen from a planned position with clean footing, tools, and a clear retreat route. Use controlled demolition tools instead of physical kicks. A massive industrial gate is being slid open when the structure suddenly jumps its track and moves downward without guided support. Large metal gates depend on tracks, wheels, rollers, stops, and guides to keep their movement controlled. When a track is dirty, misaligned, worn, or missing a limiter, the gate can climb out of its normal path during routine operation. Manual pushing often places the operating position close to the structure when the failure begins. Once the gate leaves its guide, its full weight is no longer supported in the intended direction. Safe gate operation requires daily track checks, working stops, roller inspection, secondary restraints, and enough clearance so no one stands in the gate's movement path. In a busy warehouse, a forklift lifts a stack of heavy materials before the top surface is fully visually cleared. The load shifts suddenly. Lifting materials without a clear view of the stack creates a serious blind spot. High pallets can hide surfaces that must be checked before forks rise. When the forklift moves, unbalanced weight may slide or separate from the forks. Resting on stored goods changes load behavior and removes the operator's ability to control the lift. Stacks should be checked from all sides before raising, and stored goods should not be used as resting places. Perform a full visual sweep before raising forks. Keep people off stored goods. Sound a warning horn before vertical movement. In this machinery workshop, a worker watches a massive diesel generator suspended by an overhead crane, but high above, the steel rigging is slowly reaching its load limit. Overhead, crane lifts rely on every cable, hook, shackle, and connection holding under full tension. If the rigging reaches its limit or a component weakens, load control can vanish instantly and gravity takes over the suspended weight. Before lifting begins, the entire rigging system must be inspected, rated, and isolated from surrounding activity, so any movement stays within a controlled area. Safe heavy lifting depends on thorough structural inspection before every operation. Establishing a fully protected exclusion area helps ensure unexpected load movement occurs away from occupied spaces. A group attempts to move a heavy brick wall using improvised manual force. The wall quickly tips, sending loose material into an uncontrolled structural failure. A standing wall stores weight that must be released through a planned demolition method. Once the structure begins to lean, its movement becomes difficult to guide by hand. Loose bricks, uneven force, and changing balance can send material into areas that were not cleared properly. Manual pushing gives too little control over timing, direction, and final landing area. In a busy warehouse, foot traffic moves ahead of an active forklift. The machine moves unexpectedly into the nearby marked pedestrian travel path without warning. Heavy vehicles carry momentum that prevents instant stopping, especially when loads limit visibility. Walking directly in front of an active forklift places the pedestrian in the machine's forward route. Forks, pallets, and stacked materials can hide the ground-level view from the operator. Once the truck moves, reaction time becomes short in a shared lane. Safer warehouses separate walking paths from driving routes, require eye contact at crossings, and use lights, mirrors, horns, and markings. Paint walking paths separate from driving lanes. Maintain visual contact before crossing transport routes. Install warning lights for approaching traffic. At a warehouse entrance, a worker moves under a rising roll-up door. The folding fabric catches and lifts without warning. Passing through a moving automated barrier creates risk. High-speed motors are designed to lift large doors, not to sense every unsafe movement underneath them. When clothing or equipment catches in the folding section, the machine may continue pulling upward with a strong mechanical force. Ground control disappears quickly, so the safe choice is to wait until the door is open, stopped, and clear. Let the moving doors finish their cycle. Wait a few seconds, respect automated motors, and cross only when the opening is fully clear. In a bustling factory, direct contact is made with an exposed rotating machine part. Seconds later, the equipment cycles again, drawing the contact area into fast motion. Automatic machines can restart or cycle again, even when movement appears paused. Direct contact with rotating parts is risky because the machine is built to move with far more power than a person can control. If the equipment is not isolated, a delayed cycle, sensor command, or automatic program can bring the rotating section back into motion without warning. The safest approach is to stop the machine fully, isolate energy, verify zero movement, and use guarding or tools instead of placing hands on exposed parts. On a dirt road, a crane attempts to lift a semi-truck. The lifting slings fail under pressure, and the heavy vehicle drops offline. Lifting places tension on rigging gear from the moment the load leaves support. If straps are overloaded, damaged, or positioned poorly, they can fail with little warning. That release transfers the full weight back to gravity, causing the vehicle to drop or swing offline. Recovery work becomes unpredictable when ground is uneven and the load shape is awkward. Safer lifting begins with rated gear, correct angles, fray checks, stable ground, and a clear recovery path. Verify strap weight ratings before lifting. Inspect fabric lines for hidden fraying. Maintain wide boundaries around possible release paths. On this highway, a motor grader pushes a stalled road roller up a trailer ramp, but forcing dead weight upward begins shifting the machine away from the center of balance. Pushing heavy equipment up a narrow ramp removes much of the steering control needed to keep the load centered. Uneven force from the pushing machine can drive the stalled equipment sideways, especially once the wheels or drums drift away from the ramp's center line. Loading heavy machinery requires controlled pulling, fixed alignment, and restraint systems rather than uncontrolled pushing force. Safe loading procedures avoid blindly pushing heavy machinery onto elevated platforms. Controlled towing systems with secured alignment points provide better directional stability during transport. A movable pallet is moved into loaded racks, triggering rack instability across the floor. Storage racks are designed for vertical load, not sudden side impact. A moving pallet can transfer enough force into the frame to loosen connections and start a chain reaction. Once one rack bay shifts, the weight above can pull the next section out of alignment. A warehouse with heavy inventory must be treated as a controlled work area at all times. Keep unsafe play away from equipment and storage aisles. Operate pallet movers only for assigned tasks. Protect rack structures from impact with barriers, spacing, and disciplined movement. In a busy factory, routine monitoring occurs below overhead transport. A steel block releases from the handling system into the marked work area below. Suspended loads above work areas need strict separation and backup control. Mechanical stress can weaken chains, hooks, jaws, and gripping parts over time. If a support releases, the load becomes a fast, downward-moving object with no reliable warning. The area directly below an active lifter should stay clear because gravity fixes the path. Safer overhead handling uses backup cables, routine inspections, tested lifting points, and permanent floor markings that keep routine tasks out from under suspended material. Install backup safety cables on suspended lifters. Inspect overhead jaws for hidden fatigue. In a quiet office, a worker leans too far back. Gravity takes hold, the chair loses balance, and the heavy desk loses its stability. Shifting weight beyond a stable center triggers uncontrolled backward movement. As the chair tips, feet can press against the tabletop edge and transfer force into the furniture. That leverage pulls the desk past its balance point and brings wood, equipment, and loose objects into the same movement. A simple office habit can become a serious stability problem when chairs, desks, and shifted weight move together. Keep rolling bases grounded. Avoid leaning past the chair's stable range. Protect your center of balance, and respect furniture that can shift when pulled. A forklift operator maneuvers near a delivery truck with forks fully extended across the road, creating a hidden obstacle in the path of approaching traffic. Forklifts are not designed to move through shared traffic areas with forks extended. The forks can project far beyond the visible body of the machine, making them difficult for drivers or riders to notice in time. When industrial equipment enters a road or mixed-use lane, the mismatch in size, speed, and visibility creates high risk. The safer method is to retract forks fully, use proper transport equipment, control the crossing with signals, and keep traffic away until the forklift has cleared the lane. Any protruding attachment should be lowered, marked, and kept out of public travel paths. On a street, tree trimming is carried out from a mobile scaffold. A heavy branch rebounds toward the frame and shifts the platform. Cutting heavy timber from a freestanding tower creates a balance problem. Branches may not travel straight down. They can swing, twist, or rebound as fibers split. If moving timber contacts a light scaffold, the force can shift the frame's balance quickly. The platform may move before there is time to stabilize it. Safer tree work from mobile frames requires tie-downs. Separate anchors, planned drop paths, ground clearance, and smaller cut sections before the saw reaches the branch. Secure tall frames with strong tension ropes. In this footage, a tractor pulls another in a high-tension competition. Without warning, the pulling machine lifts onto its rear wheels and rotates backward past its stable balance point. Heavy towing puts extreme torque through the tractor frame. When the tow load resists movement, the engine force can rotate the machine instead of pulling it forward. If the front end rises past the balance point, the tractor can rotate beyond its recovery point. High-tension pulling needs controlled limits, proper equipment, and enough open space around the machine. Respect towing capacity and hitch height. Avoid sudden throttle under heavy resistance. Use equipment designed for pulling so that torque does not turn into uncontrolled rotation. Inside a plant, a worker loosens the lid of a massive reaction vessel. Stored pressure forces the hatch outward. Opening sealed tanks before fully releasing internal pressure creates a stored energy risk. Trapped gases build force against the hatch. When the final bolt loosens, pent-up energy can release at once, driving the steel lid outward quickly. The opening path, nearby platform, and work area can be affected by pressure and moving metal unless gauges are verified and the area is cleared. Verify zero pressure before loosening hatches. Stand clear of the opening path, release pressure fully, and confirm conditions before opening sealed equipment. At a concrete plant, bulk transfer begins from a pressurized cement tanker truck. The connecting hose coupling releases, sending a thick dust cloud across the work area. Pumping dry material requires strong air pressure to move heavy powder through the line. If a connection clogs, trapped energy searches for the easiest escape path. A weak lock, worn hose, or loose coupling can release quickly under that pressure. The nearby area can fill with dust and force, reducing visibility and control. Safer transfer work uses locked couplings, distance from pressurized lines, steady communication, and hose inspections before airflow begins. Secure all locking mechanisms before starting airflow. Stand away from pressurized lines and inspect rubber hoses for hidden wear. To keep learning from these important workplace safety lessons, make sure you subscribe and turn on notifications. Stay aware, stay safe.